So factorial calculation can get quite large in very short amount of time. So let's see what was the 10 factorial was somewhere around 362,000, and let's say 11 factorial, and let's try 12 factorial. As you can see, number is keep getting larger. So what is 20 factorial? It's a pretty huge number. So how about 100 factorial? This is a pretty big number. So I'll do one more example. And then what is 1000 factorial? So this is an incredibly huge number. So how many? So this is the 100 factorial. Then the question here is, how big of the numbers programming languages can support, and then let's discuss this. So let's talk about the limits of integers. While there are an infinite number of integers, there is a finite range of ints that can be represented with computers. This range depends on the number of bits a particular CPU uses to represent an integer value. And in most cases, it's either 32 bits or 64 bits space. This means that there are, with a 32-bit computer, there are 2 to the power of 32 possible values centered at 0, which means that this range is negative 2 to the power of 31 to positive 2 to the power of 31 minus 1. So this is roughly somewhere between a negative 2.1 billion to positive 2.1 billion. So this is the largest integer most computers can support. However, when we did 100 or 1000 factorial, the numbers were quite large. How did Python did this without any problem? So the newer version of Python automatically convert your ints to expand from when they grow so large as to overflow. When we get indefinite and large values such as 100 factorial at the cost of speed and memory. So Python is able to calculate that compared to other programming languages such as Java, C++. However, we get some speed and memory problems with this.